And this is going to be our task. But first, let's create a, you know what, let's read it first. Yeah, let's read it first. And then we can move on with anything else. Okay. So you guys all have it, I hope, in the chat. I sent it in the Python hub. You can open it in Visual Studio or type, what is it, PyCharm. Okay. Let's read it. We use electrospray ionization, ESI, for quality control of synthesized CRISPR guide RNA. Now, the thing about these sort of interview tasks, I've seen it quite a few times, that they put there some really intimidating words that you're not familiar with, and you don't actually have to be once you read the task. But the first sentence will already scare you away with this one. But once you keep reading, you'll realize the task will be a lot easier than having to do anything with this. This is more like what the company is specializing in or what they are working with at that moment. Let's read forward. So the instrument manufacturer provides analysis software called Messhunter. While we have moved the computation from on-site desktop machines to Amazon Web Services, Elastic Compute Cloud virtual machines, we continue to run the software on Windows. We have since overhauled the logging information, but previously a hexadecimal representation of the virtual machine's Internet Protocol version 2 IPv4 address was logged as the hostname. So this is what they're talking about. These are the logs that they have. And we're going to have to work with this log. And this is what they were talking about. The IP address is this in a hexadecimal format. So our task is to write a Python code to convert hexadecimal IPv4 address to decimal dotted quad notation. Now, this one is also, again, might be a little confusing at first, but what all they are saying is decimal, yeah, like the standard notation that we are working with. So decimal, so it has to be in decimal system. We are using the decimal system. And then dotted, they mean like it should be separated by dots, and quad, like split into 4 parts. Okay, and then they just say like this meant to be a quick demonstration of your ability to code, and so on and so on. Ignore performance and error handling. That's especially error handling. I think that's a nice help for us. We don't have to write like so much more code. And they ask us to share the screen and communicate the thought process. So yeah, in the meantime, while you're writing the code, you'll also have to talk about this. And that's really common for online interviews. And you can use the read, evaluate, print loop. So this is basically like including for built-in help. So yeah, you have like an option like help in the interactive shell, for example. When you type help, I'm in the function, it will show you like some basic help info. And you can actually put in some function name over here, like help print, for example. It will display some info about, am I wrong about this? I think it should be print. I think it should be help print for sure. Yeah, like this. What happened here? Okay, it was something else. So help print, it will like display the signature of the function, but also it will give explanation about the different parameters in the function and so on and so on. So this can be handy. But I think the Python doc beats it all. Like that's probably the handiest. If you need anything, you'll find the same info over there too. And before we jump in, maybe it would be nice to overview the number systems a bit, like what we are doing here, what is hex and all that. I think you guys learned it, but just a little quick overview. So suppose so we want to convert from one number system to another. What do we do? Well, let me zoom out a bit. Okay, so let's talk a little bit about binary first. Let's see our own decimal system. So the way we represent numbers in the decimal system is that the position determines what exponent of 10 we are working with. So decimal is all based on 10. And this is why we have like tens, hundreds, and thousands positions. This is like floating point already, but let me give a simpler example. Just a moment. Yeah, this one. I think this one will be nicer. Yeah. So, or basically, okay, I can't find a nice one, but suppose we have the number 689. If we have this number, what it's describing is basically that this is the 0th exponent of 10. The 0th exponent of 10, everything, the 0th exponent of everything is going to be equal to 1. So 10, 0 is basically the same as 1. And this one, the second decimal place is going to be the first exponent of 10. And the third, yeah, and the first decimal place is going to be the second exponent of 10. So what it's saying basically, that this number is the same as 6 times 10 squared plus 8 times 10 plus, so yeah, 8 plus 10 to the 1, but basically that's 10. And then 9 times 10 to the 0th. Yeah, this is 10 to the 1, but basically 10 to the 1 is basically the same as 1. The same as 10, sorry. And 10 to the 0th is the same as 1. Now, if you actually plug it into a calculator, you'll see that we don't even have to do that. Actually, we can just calculate it in our heads. But this is like 6 times 100 plus 8 times 10 plus 9 times 1. Well, it's basically 600 plus 80 plus 9. So it's very intuitive, you know. Of course, when we are working with it, we don't actually think about the different exponents of 10 when we're working with decimal. But the reason why it's worth thinking about this a bit is because the same idea can be applied to suppose binary. If you want to work in binary and you want to see, okay, what is this number here? Well, we don't know, right? If we look at it, we don't know what it is in decimal, but we can easily calculate it because the same idea applies here. That is just the exponents, different exponents of 2. So this is going to be 0s, 1, first, second, third, fourth. Sorry, this one is third, fourth, fifth. And of course, we don't know these, but we can calculate them. But basically, the fifth exponent of 5 is going to be 32. So this is going to be the same as 1 times 32 plus 0 times 16. I know, like this. Okay, let me write the actual value of these on top of them. So this one is going to be 32. This is going to be 16. This is going to be 8, 4, 2, and 1. And the way we calculate it is we say, okay, 1 times 32, 0 times 16, plus 1 times 8, and then plus 0 times 4, plus, and I'm running out of space, but it's kind of okay. Okay. 1 times 2, plus 0 times 1. And now if you add it up together, it's going to be the same. 32 plus 8 plus 2. Hopefully I didn't miss any other ones. Yeah, like this one. Yep, this one. Rest of them are zeros, so we can ignore them. And this is going to be the same as 42. And now if you type this into a calculator, we can make sure actually we have like programmer option on the default calculator. And you type in Well, you can type in the decimal also just to see. 42, you can actually see that this one is the same as the number we have over here, the binary number over here. There are like just zeros over here in the beginning. But this is like optional. You can completely ignore them in the calculator because it breaks it down to bytes. So this is 1 byte. 1 byte is 4, or sorry, 1 byte is 8. So wait, yeah. But basically it groups them in 4 just so we can see it clearer, much clearer. The point is that decimal uses a 2-base system because it uses the exponents of 2 to add together the number we are looking for. And the same applies to any number system. So if you have, for example, in our case, the exercise is going to be hexadecimal, it's going to be 16-based. So it's going to use the exponents of 16 instead of 2. But for 16, we need to understand that the way they represent numbers is we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And after 9, we're going to have some special symbols. We're going to have basically the alphabet up until F. So, E is going to be equivalent to 15. And then, you can calculate these, like this is going to be 10, this is 11, and so on and so on. You just have to add the corresponding number based on the position in the alphabet. So this is like 12, 13, and what did I do? I missed like F. This is going to be actually 14. Fix this one. So this is going to be 14. And this is going to be 15, I'm sorry. So yeah, that's how we represent numbers in hex. And now the idea is the same. First, I just showed you the conversion from binary to decimal, and I'm going to show you now the conversion from hex to decimal. And also after that, we can look at it how to calculate from decimal to binary and decimal to hex. But I think first it's easier to just understand the reverse conversion. Okay, let's do that. So let's start with binary. So let's do the hex conversion first. So suppose we have some hexadecimal number like F A, for example. If we were to convert this, this is going to be the same as, let me zoom in a bit, 16 to the power of 0 and 16 to the power of 1 times F, 16 to the power of 0 times A. So let me write this down. So 16 times F plus, yeah, this is same as 16 basically. I didn't type it out because it's the same value, but yeah, idea is the same. And the 16 to the 1s times A. Now, what we know is that F is going to be the same as 15. So this is going to be 15 times 16. And this one is going to be the same as A times 1. I cannot switch the order, but you guys get the point, I hope. So, oh, sorry, 8 times 1. I mean, this is going to be 10 times 1 because A has the value 10. And now if you calculate this one, for example, this is going to be, I'm not going to calculate this in head, but this is going to be 250. Let me take it down. 250. Now if you check it over here, let's type in the decimal. 250. You see the hex value? It's FA. So that's kind of the idea. And let's see another example. Suppose you have something, because hex is like so weird. Like you will have things like numbers and letters mixed. Suppose we have like A3. We want to know the value of this one. Or let's also add another one just for fun. Let's do 2A3. So this is going to be 16 to the power of 2, 16 to the power of 1, and 16 to the power of 0. Now if we have to just apply the same principle as we did before. So this is 16 squared times 2 plus 16 times a. Again, like you can leave the exponent here because we know it's the same value. Plus 3 times 16 to the 0th. And if you calculate this one, this is going to be, let's calculate 16 squared. 256 times 2 plus 16 times, now we know a is like 10. We remember that, like here. Plus 3 times 1. Why 1? Because anything to the 0th exponent is going to be equal to 1. And now if we just add these together, I'm going to just type it in. It's 1155. Let's see if that really is the case, just to make sure that we were right. And what happens is, okay, this time I will just type in the hex value. And let's see if we get back the same value as we wanted. Here's the decimal one, 675. Maybe I made a mistake in this case. Let's see. This is also good practice to see where we made a mistake. So this is 16 times 10. I think I just made the mistake while typing it in over here when I was calculating it. This is 16 times 10, not 40. Yeah, okay, here we go. So only in the end. Basically, we have the same number, the same decimal in that case. 675. This one is wrong. Ignore it. 675. So that's how you can calculate from hex to decimal if you have to do it manually. And it may be a coding issue, like you have to convert hex to decimal manually or binary to decimal manually. The one we are going to be looking at is not like that. We can use anything. They don't mention that we have to implement it from scratch. Now let me get back to binary again. I just want to show you guys how you can calculate binary from the decimal value, because this is also useful. So suppose you have a number like 34 and you want to see what it's like in binary. What you have to do is you have to divide it by 2, and if you get the result, you have to do integer division. So when you divide 34 by 2, it's going to be equal to, again, this is like integer division. In your head, you have to do integer division. Or of course, you can also type it in the calculator. And when you do this one, you'll see like, yeah, this one is going to be, okay, we'll see like with an example when it's not an odd number. When it's not an even number, like so say for example, you have to divide this by 2, then instead of 8.5, we're just going to use the integer 0.8 in that case. So integer division, just like in Python when we use the double sign like this. Okay. So in this case, it's a whole number. It's going to be 17. So what you do over here is you type the result below, and you put the remainder over here on the right side. The remainder in this case, we know 34. You can use the modulo in your head. 2 is going to be 0. So we're going to put the 0 over here. And then we repeat the process until we reach 0. Basically, that's the idea. And then, for example, 17, as I mentioned, if we divide it by 2, we already know it's going to be 8, and the remainder is going to be 1, because 8 times 2 is 16, plus 1 is 17. And for 8, then we can do the same. Divided by 2, it's 4. Of course, it's an even number, so there is no remainder. Same with 4. We can do that. And then we're going to have 1 over here. And then for 1, we are going to have a remainder of 1. And then we reach 0, basically. Once we reach 0 in the end over here, our process is done. And the way you read this is you read it from here. So you have to read from the bottom to the top. And then you write it down like this: 0, 1, 0, 0, 0, 1, 0. And let's make sure that this is actually correct. I'm going to enter 32 and 34, not 32. And here we have the number. This is the same number as we calculated over here. So this is how you calculate binary from scratch. Should we do another one?
Yes, please.
Okay, let's do another one, because I think this is somewhat harder than calculating the decimal from binary. That one is a little more straightforward, like you can read what you're doing. But in this case, yeah, let's do. You guys can suggest a number. We can do any.
77.
77. Okay, let's try it. In this case, yeah, I'm just gonna calculate here because I'm lazy to calculate in my head and I'm prone to mistakes. So this is gonna be 38. And as you can see, there's a remainder in this case, because this should, if there is no remainder, it would be, there will always be a remainder if it's an odd number. That's like the easiest way you can just remember. And the remainder is 1 in this case, of course, because we are working with binary. So we're dividing by 2 always. And in this case, this is going to be 19. And the remainder is 0. And for 19, it's going to be 9. 9 times 2 is 18. So there will be a remainder of 1. For 9, we are going to have 4. And again, there will be a remainder of 1 because 4 times 2 is 8. So there's a remainder of 1. And here we have a remainder of 0. And 2 times 2 is going to be 4. So yeah, remainder is 0. And we divide 2 by 2 is going to be 1. And this is going to have no remainder. And this one's going to have a remainder of 1. And we reach 0. And basically, we found our value. Yes, so Asker also mentioned, like, yeah, you can also just use the trick 64, 32, 16, 8. For yeah, this is for, I think this one was for this part. Like if you remember these, you can just add them together in your head, like 2 times, like 2. Like you just look at the parts where you have 1, and then we're like, okay, 2 plus 8 plus 32. If you can visualize it in your head, just to speed up this process. Okay. Yeah, it's easier, true. And after some time, if you work with these, you'll remember like a 1, 2, 4, 3. Yeah. And this, we read it from the back again, like bottom to the top, as always. 1, 0, 0, 1, 1, 0, 1. There we have it, and hopefully it's going to be correct. Actually, we can enter the binary value. Let's do that. 1, 1, 0, 0, 1, 1, 0, 1. And the decimal is 77. Really nice. That's exactly what we wanted. So that's how we can convert from decimal to binary. Is this one clear?
Almost.
Almost. Okay. Like which part is confusing? Or it's not that easy to pinpoint it?
So you basically, you divide everything by 2, and then you just find
These
the
are going to be
remainder.
the,
That's what you
yeah,
see
these
on
are going to be the
right side.
remainder. Exactly, yes.
Until you hit 0 on the left side.
Exactly, yes. So basically the remainders are what's going to add up to the binary value.
And why we divide by 2? Can you explain?
Because that's the thing, that binary is 2 based, and always we divide by the base to get the number.
Yeah,
actually, maybe
easier.
we can also try like with 10, if we divide
Okay,
by,
and the decimal is 10 based, and the hexamal is
Yeah.
60. Okay, got it.
Like if you were to do this with 10, you would get like This is going to be the remainder. This is going to be 7, 7, 0. That's the beauty of it. You can apply it to the same number also, and you get back the original number when you divide it. Like if you use by 10, you divide by 10, like it's going to be 7 times 7. Yeah, but it's important that in this case, you cannot just say like 11. You can just type like, oh, I divide by, oh, sorry, we're dividing by 10. What am I talking about? Yeah, so this is going to be, if we divide it by 10, this is going to be like 7 times 10, and the remainder is 7. And here, divide by 10, it's going to be 0, and the remainder is 7 again. I know it doesn't make sense because we are getting back the same number, but I'm just showing you that you can convert even from the same system to the original, and it works.
Well, what if we have a binary and we want to convert it to decimal?
This one, you can use this one, like just write it up like here, like I'm gonna just write up the instead of the exponents, let's just write up the actual number. So this is gonna be 0, 1, 2, 4, 8. You basically double it always. That's how you can easily remember that you just have to double the number starting from 1. And then 32 and 64. That's really ugly. 32, 64. And basically just circling the ones you're interested in. This case, these. Although it's quite ugly. Maybe it's better if I don't do it. And then you have 64 plus 8 plus 4 plus 1. And then you just add them together. Okay, 5, 13, and that's 77. Correct. That's how you calculate it.
Okay, makes sense.
Yeah, and these are just the exponents of 2. Like this would be, you take the position of this one, like this is the 0th position, first position, and that will be the exponent, like 0, 1, and so on. That's the idea. Now let's do this. Let's do the same with hex. We want to get back the original. Oh no, sorry, the hex value from the original. Like suppose, just say some number, any number. I think it's gonna be larger numbers now because hex is pretty short, so it will be much shorter, even if we use a larger number. Okay, I will just come up with some. Let's try to do this one, like 4,895. And we want to get the hex value of this one. What we do is the same technique again, 4,895. 4,000. And then we divide by 16, 305. So this is what we're going to have, 305. And if you want to get the remainder, you just have to basically multiply by 16. We have this number, and we have to subtract this number from the original, 4,880. If we subtract that from 4,895, that's going to be 15. So it's going to be 15. We can actually write it even here, like 15, and later on we can just convert it. Like this is going to be A, and so on. This could be also a technique. This is easier if you don't remember. Oh, sorry. You see, that's why it's worth writing it down like this, because you write some stupid thing like me. So this is going to be F in that case, but we can do this in the end. Let's just do it like this now, for now. Okay, 305, we do the same thing. 305 divided by 16, 19 times 16, 304. So actually the remainder will be 1, and new number will be 19, because 19 times 4, 19 times 16. Okay. And this one we can also calculate quite easily. This is going to be 1, and this is the remainder in this case is going to be 3. And over here, the remainder will be, the new number will be 0. The remainder is 1. And we just have to convert the numbers that are larger than 10, larger than or equal to 10, to the symbols. Like this one will be F. can see over here. And now you have the number 131F. And hopefully it actually is that number. If not, that will be awkward, but let's see. 4,895. Beautiful. So that's the idea. Should we do another one in hex?
Yeah.
Okay, let's do another one. Let's do 7,761. And then we divide by 16. 485. This is going to be the new number. You can check the remainder, but you can actually just even type it over here. Check the remainder. 16 times 485. Remainder is going to be 1 in this case. And 485 times 16, 700. Oh, I mean, divided by 16 is going to be 30. And again, we can just take out 16 times 30. In that case, remainder will be 5. And this we can actually just calculate in our head, honestly. It's going to be 1 times, and the remainder will be 14. 14, yeah, let's just type it like this. We can later on convert it to a symbol. And again, we are in a situation where we have a 1 in the end. So this one will be 0, and this one will be 1. 1, and then 14 is going to be E. So this is going to be E, 5, and 1. And that's it, basically. We can enter the number 1E51. And this is the original we get back then. Yeah, so that's how we can calculate it on paper, or if we have to implement it in a program and we have to write it from scratch, that's how we would do. We would basically do the same in code. Just we would use the modulo, integer division, and that's it. Any questions about the number systems, how we convert between these? No? Not for now. Okay. I think we can try to work on the task now then, because the idea is the same. We have to convert from hex to decimal in this case. Okay. So we read this part. Actually, we read the whole exercise. We know what we have to do. But let's look also at the logs and see what's going on over here. Now, I didn't see the specification of what we need, whether we need to load the logs or we have to work with the values that were already given. It's a good question. We could also work with the logs, sure. Let's just do that one. Actually, I already made some logs over here. Like I copied the logs from the exercise. And this one is separated by tabs. I wish I could show it somewhere. But the point is this over here is like a tab, not a space. Let me see. I think there's an option to show the tabs. Well, I can kind of prove it with this way. Like, let me show you. If I do here and look for the tabs, you'll see that these are separated by tabs over here in between these. I hope that it's clearer over here this way. Let me send you the logs, and then we can work with that. This is gonna be the logs. I'm gonna close this, and we can start from scratch. And this MD file, let's create a, first of all, let's create a directory for the project. Let's say IPX. I'm just gonna call it like this. And create a Python file. TF. Sorry. Where is my head? Mainnet py. Okay. And then over here, I'm gonna add the README. The MD file that I sent you guys, we can use that as the README. I have it in this one, so I'm just gonna copy from here. And the repo is gonna look quite nice then. Okay, here we have the README file. This is gonna be like this. Actually, I'm gonna commit these just to show you. So here you can select like what you want to commit, just like it in the command line with the git add, but it's easier to just use the GUI, the graphical user interface. All this, pretty much all the major IDEs have, I think all of them actually have git integration or version control integration, and then you can use it from the graphical user interface and then enter something like edit readme plus, you know what, let's just add the README for now. We can also just do that and add the other one later. You can commit it, and suppose you commit it and you didn't push it. If you wanted to push it, I believe you can open over here and just click on your local and click push, and then it's going to create, like, going to push it to your remote. We can actually check the remote in a moment. I will just look it up. So the remote DevOps. Here we have it. If you go over to IP hacks, you're gonna have a really nice README for the tasks that we are working on. That's why I'm like, okay, we can create separate directories for the different DevOps tasks, and whenever you need to access it, we'll have like really nice description. Now, of course, if you're lazy to create something like that, of course, you can just put the PDF in there instead, and then just read the task if you need to revisit it in the future. Okay, let's just see what we have to do. So here we have the description. And let me also get the log file from the previous one. This is the same as I sent you. Gonna put it in here. And again, like what you have to keep in mind is that this is a tab and this is a tab. Rest of them are like spaces in here. Oh, this is a tab, this is a tab, sorry. These. And what we want to get is the second chunk from here, this IP something, the name of the instance that contains the IP address. That would be the idea. So let's just see what we have to do. Suppose we are at the interview. We know that we can use the docs, the Python docs, if we need to. That's pretty handy. Let me just, I think I have it open over here. Okay. We can use the Python docs. They allowed us. This is really nice. And you can just write down what your thoughts actually when you're working on an exercise like this. I think it's pretty handy to write it down because it's easy to forget it. So in your head, you come up with some sort of a plan. Suppose in this case, the first step would be, okay, read the logs into an array. But by reading, split line by line. And we can add something like while reading, we split the line into by the tabs. Again, I'm talking about this part. We're gonna split it by this part, and we're gonna get the second chunk or second part, and get the second part, the IP. This one. Okay, now once we have the array with the IPs, what is going to be the next step? In fact, let me ask you guys, what would you do in this situation? You have the array with the IPs. What do? You have these IPs, like with everything. What would be?
Remove IP dash.
Yeah, that could be a valid option to remove the IP prefix. I will put this in quotation. This could be the next step. And then what will be the next step? What would be the next step in this case? So now we have a list of these.
Convert the decimal form to the decimal form, right?
To convert it to decimal, you said? Or I couldn't catch it. Could you say it again?
So they're at the hexagonal form, right? Right now,
Yeah.
shouldn't we convert it?
Yeah, we have to convert. That's right. What you have to note, however, is that this is going to be one part within the dotted notation. This is gonna be like this one, the first two, because the thing is, in IP addresses, and let me get back over here. So we know that IP addresses, the maximum value is like this one, 255. This is the maximum value you can have for an IP address. And the reason for this limitation is that it's not out of nowhere. This is the I think 16th. No, the 8th power. Yeah, this is the 8th power of 2. And that's for 16, that's gonna be the second power of 16 actually. So now that you know that this is the second power of 16, you know that, okay, so these two characters actually add up to this one just in hex. And then these two, for example, add up to the 16. Oh, sorry, these two add up to 16. So basically these are 4 separate parts already. They are just written together. So when you convert it, it's really important to convert it in a group of 2 instead of converting the whole one, because if you convert the whole one, you will get a pretty huge number that doesn't make any sense. And I can show you guys from here with the calculator, we can actually see already. If I enter the hex value 0A, 0A is actually the same as simply A, is going to be 10, which is the first part. And for the second part, it will be 10. Let me switch the hex again, 10. And that one will be 16, just like this. And then the third part will be 21. And that one will be 33, just like here. And now if you were to enter the whole number into it, it wouldn't make sense because it would combine into one number that is different. You see, it would be this number, which is not the IP address. So we have to convert it in groups of 2. So the next step would be, in fact, this one, the IP prefix. We need to add an additional step before. We have to create this dotted quad function, because that's what they were asking for, to create this function. And you see this function takes the IP in its whole format, so we cannot remove the IP before. The function will do that, so it's an important step. It's good we have it, but we have to create the dotted quad function. Dotted quad, yeah. Create a dotted function. And then these will be what we do within the function. Okay, so we remove the IP prefix. And then what we have to do is we can iterate through this in a step of 2. So iterate through with a step of 2. So 2 at the same time. And convert parts into decimal. So the way we're going to iterate is going to be like this, then this, then this, and this. So in a group of 2. And once we have that, what do we have to do with the decimal value? What are we going to do with those
Join
values?
using dots.
Append, join.
Okay, first, I think
Divide by 2.
wait, who I couldn't see the name, but who was the first one who said something?
It's a Parvino.
Oh, no, before, but yeah. So you said divide by 2, you said.
Yeah.
But
Andre?
yeah, I think it was Andre, but no, but in this case, this is hexadecimal if we want to convert, or what do you mean by divide by 2? Maybe I misunderstood.
I thought you were asking about the decimals, how to convert into binaries. No, right?
Oh no,
Okay.
we don't need binary. We will keep
Oh,
them in
okay.
decimal format.
Yeah, then never mind.
So basically, in this case, we have to create a list, and we have to append these values to that list. So I'm not gonna write the creation of the list in the description because it will be very obvious from what I'm writing here. I'm just gonna say like append the parts to a list. If you write this one, it's very clear that you have to create an empty list before. And once we have the parts, what can we do? I've heard actually an answer that was right previously.
Join was that?
Yeah, I think you said Sahi, that we should like join the parts by a dot actually, because this is going to be like dotted quad notation, so we can join them by a dot. And basically that's it actually. That's all we have to do. And for this one, it's not going to be that interesting to use this, because we're going to print the same IP address like multiple times. But suppose, just imagine that we have different IPs here, just to make it more interesting. It could be any IP over there. In fact, we can rewrite and add our own IPs. Suppose. I just added like one more just to make it a little more interesting, because otherwise we would have the same IPs like 10 times, or I don't know how many this is. Okay, so let's try to do this. Let's try it. So the first step would be read the logs into an array line by line. So what we could do is we need an array. So we can say, and by reading we split the line by the tabs and get the second part. So already we get the IPs. So IP list, we could create something like this. This is where we're going to be storing the IPs. And now we are going to create a file stream. And we can use actually something like width, which is what it does is that it closes the file stream immediately after we stop using it within Python. I can show. So the with statement like this. like this. So why it's good is that immediately it closes the file stream. Otherwise, it would be open throughout the execution unless there's some memory management that handles it. So it's just a good practice to use it this way, unless you like manually close it later on, like this one. Especially it's for writing into files, it will be handy. I will show you guys an example, like what happens if you don't close the file stream. It's just not going to be saved, basically. But for reading also, it's really useful. So we're gonna open up the logs.txt. Oops. The tooltips are really huge. Logs.txt. Yeah, that's one of the things I like about PyCharm. It just shows up the file name, so you don't have to remember all the file names within the directory. So this is a relative path, basically. We're opening up the file from the same folder, so we can just specify the name. We don't have to specify the whole path. And we can add as, and we're gonna add file, or we can say log. So this is gonna be our little file stream. The log is going to be the file stream. And what we can do is we can read the lines. And this one will be like lines. I'm just gonna store it. So this one reads the whole file into lines. So line by line, we're going to have it. In fact, let me print it so you guys can see what's going on. So this is it. This is like a huge S array, and that's where we store all the lines from the logs.txt. I wish we had like a nicer output so we could see it nicer, but let me just, you know what? We could do like this. The beauty of Python. So here we have it. This is like what we have within the array. We have all these lines. Okay. And now we want to go over those lines. So we can say for line in lines, for example. And then we can do this. You know what? I'm just going to copy this and we can put it over here. So we'll see clearly what we are doing. So here we have to split the line by the tab. This is a special character like the tab. This is like the escape sequence, the backslash. So we can add like special characters like new line and all that. I think you guys know already. And for tab, it's going to be \t. And it's not clear again, like that this is a tab, but if I enter t over here, it's pretty clear. Okay. And we need the second part. So index 1 actually in that case. And that one will be the IP. And we want to store it somewhere. So let's append this one to the IP list. We're going to append this to the IP list. And now, basically, that's it. Once we are done with it, let me print the IP list so you guys can see that it actually worked. This is what we have. We have the IPs. Now, I'm not sure if this was actually part of the task in the interview, but I included it, you know, better to have some extra practice. But now let's focus now on the main task, which is actually processing this. So how do we do that? First, we are going to need this dotted quad function. So we're going to create this dotted quad function. And we're going to remove the IP prefix. There are multiple ways we can do this, actually. One approach could be to, let me move this up a bit. So one approach for removing this would be, oh, and this is going to have a parameter, which is going to be like IP, let's say. So an approach could be to split it. Oh, and by the way, you can add like type notation over here. This is like how you can denote that, okay, this is of string type. That way, for example, when you type dot, it's going to show you all the string functions, because otherwise it wouldn't know that it's a string. it cannot show anything because it doesn't know the type of it. So it's really nice to add some notation like this. And once you have it, you'll have like split and strip and all that, like all the string, different methods on strings. Yeah, and one way you could solve this is by saying, okay, I'm gonna split this by the dot and, oh, sorry, the dash, and then I will take the second part. This is a totally valid way. And I'm gonna call
Excuse
the
me,
function.
if we do IP dash instead
Yes.
of dash, it will result in the same. Yeah.
IP dash.
Yeah, IP dot split instead of dash, IP dash. Because it starts with IP. All the IP
Oh, you mean
addresses.
like that? Yes. Yeah. That's also okay. Yeah. If you
It's
mean
the
like
same,
for
yeah?
all, yeah, it's the same basically. Only or wait, I think yeah, if it's leaving an empty one, like let me see. Because in that case, either it's splitting it into an empty and then the second part, or it will only be the second, but I think it's gonna leave an empty part on the left side, but let me see. So let me call this function with the first IP from the IP list, just so we can easily test it. And then if we split by IP list, yeah, it's gonna be empty, right? It's gonna be empty in that case. And I'm not gonna print it for now, just to make it easier. Okay, so this is gonna be empty in that case, so you can use that. Yeah, that's valid also. Or you can use just the dot, and then it's gonna split into these two parts. Or another option could be is to simply select the from the third character, or wait, how many? I have to count. So 1, 2, 3. So this is 0, 1, 2. Yeah, from the third character, we can actually also just print it, and then it's going to do the same, basically. This one is also, like, each of them have their advantages. You can imagine why. For example, if you split, then what if they change this and they say, okay, from now on, we are going to be using a colon instead. Then it breaks the code. Now, of course, they should notify you in advance, but it may happen, who knows? What about the third one? What if they add something else in the beginning? Then that one will break. So you see how all of them have their own advantages and disadvantages. You can use either of them. For this task, it doesn't really matter. We can use let's just keep it as this for now. I think we can use this. And then let's say that's how we get the IP itself. I'm gonna actually reassign it, because we don't need the original value. So we can just reassign in this case. If you do need it, however, it's not the best idea. But we know that we don't need that for sure. And now we can just convert it. The first thing we have to do, and this one will be like, let me edit. First thing we have to do is iterate through it with a step of 2. So what we can do is write a for loop for I in range. And we know that the length is going to be 6, actually. Always it's going to be, or 8, sorry. Always it's going to be 8. So we don't have to worry about different lengths. But the point is we have to write. Well, actually, sorry, yeah.
Like length function and length IP.
Yeah, we can use the length also, like the IP, length of the IP, and go
Step 2.
step of 2 exactly, yeah. But because we know the length is gonna be the same always, we can even type like 8 in this case. But yeah, in this case, but it's all right to use this one. And then what we do is,
Can we skip the start point in this case, or we have to put 0?
I think it's not possible to skip it. I actually checked it while I was preparing it. If you notice that, so the issue is that the stop is a positional argument, and so is the step. But for the start, yeah, sorry,
Yeah,
I think it's not possible, because it would be like this. in that case, but I think it's not allowed. Yeah, range takes no keyword arguments. Because we don't have keyword arguments, if you just enter this one, it will think, okay, so this is gonna be from the length of the IP to 2. So we cannot
Also, it's
skip it.
consider
Yeah.
length as a start.
Yeah,
Okay.
it will treat the length as the start. That's the issue. And you know, the way we could resolve is just use a positional argument, but it's not possible. So yeah, we have to add it in that case. Okay, let's see. So now 0, 2, 4, 6 looks good. And what we have to do is we want to check. We want to slice the array. We want to slice from the ith element to I plus 2 element. And if we slice it like this, we're going to get chunks in 2. This is a nice way we can do this. So yeah, slicing is really handy in this situation. And now all we have to do is just put all these parts into an array. So we can say IP part, we can use parts in this case again. And then say parts to depend. And then we're gonna add IP that we had over here. The one that we split. And now, if we have these, let me just print it for now. We have these parts. That's it. All we have to do is just join them by a dot. Whoops. And let me also return it. And now we have no output because we want to print the returned value. So let's put this inside the print. And there we go. And I completely forget that we also have to convert it. It's not a bad idea, of course. After all, that was the specification. So, but we did the part in advance. I kind of forget to read my own documentation. You see, don't fall into my mistakes. And when we have to convert this one to decimal, we could do this before or after appending. I think before will be easier. Let's say part. And then if we want to convert it, if you don't know it, that's fine. If you open up the documentation and just type in hex, because you want to convert from hex, you will notice that if you go to the hex documentation, if you read a little bit, you can already find like C, also int for converting hexadecimal string to an integer using a base of 16. So you already have the answer. You just have to find like how exactly it's done. And if you go over to int, you will notice that there's like a positional argument base. And this we can make use of that one. We can enter 16 for the base, and then it will convert from hex. It actually writes it over
IP instead of X, right?
Yeah, instead of X, it will be the IP. Yes. This one, the X is basically, I think it's, yeah, typically a string. It can also be a float, I believe. But yeah. And then we can do this one. Int part. Well, yeah, we don't use the IP in this case because we named it part, but yeah, the same idea. Part is gonna be like these parts of 2 characters. And then we add 16. And this one will return the number that we need. I'm just gonna put it into the append. You'll see from the return value anyway.
Do we have to put base equal to 16, right?
In this case, it's not necessary because this one is just in the second position. So if we use it based on the position, we can also just write in 16, that's fine. But if you want to specify it like that, that's also completely acceptable because it's a positional argument. So if the positional argument is in the second place, for example, we can just type it, I think at least. The issue here is not with this one, actually. The issue here is that it converted into an integer. We need to convert it back into a string if we want to work with it as a string. And then we have the answer, actually. So yeah, in this case, if you want to specify the the base, you can also do that. That's also okay. Yeah, basically. Because it's a positional argument and it's in the second position. So once we reach the second position, we don't actually have to explicitly
It already
state.
knows.
Yeah, it already knows from there. But it's nice, actually. It's nice because you can read it like, okay, it's base 16, actually. You know what? I will even leave it like this because it's nice. You can read like what exactly you're doing. When you have like, I don't know, 10, 15 arguments, it's a little bit hard to keep track of them. So that's why positional arguments can be nice. Okay. That's it, basically. And the last step is that, oops, this one goes here. And the last step is that we read the logs. Instead of using just one, we are going to use them all. We could do this one, IP list for IP list. We could just like IP, print it. And let's see our mystery IP address that I added. It's gonna be this one, it seems. Just a little bit different. I think I didn't change the first one, it seems. Yeah, this one. We can actually change that one too, just to make it slightly more interesting. There we go. Yeah, that's the idea of how we can solve a task like this one. Any questions?
This one was tough.
This was tough.
Yeah.
Oh, there are quite some parts, but to be fair, I'll give you guys some motivation. If you do some code wars tasks, they are harder in the sense that you have to come up with some sort of an algorithm. These when we iterate through and just manipulate it a little bit, they're not really that complicated. It's just you have to get used to them, and that's it. They are not there's nothing actually really complicated in what we are doing here, if you think about it. It's just that it consists of several parts. That's why it may seem like harder at first. But when you compare it with the code wars issues, actually for the code wars issues, you have to be tricky sometimes. You have to think of some algorithm. But in many cases here, if you're just processing a file and you're printing out some parts of it, it's not really something complicated. It's just that you have to get familiar with the built-in functions and all that. So they require different skills a bit sometimes.
Could you share that?
Yeah, I will for sure, yes. And by the way,
So-
now that we are done, also, I hope you guys created the repo. I really hope. You can commit the main.py, even the logs actually, if unless you like want to change it with something else. But yeah, it's okay. We can add the logs also. Then we can add like us done. I don't have any nice description for this one, but yeah, us
Also,
logs.
can I ask a question?
Sorry, I couldn't catch it.
Yeah, can I ask a question?
Yeah,
Can you
of
hear
course, of course. Mhm.
What do you think about object-oriented programming? Should we study for that as well as a DevOps?
Yeah, it's possible, of course. We could even rewrite this in object-oriented way, but I think like Python is not really that object-oriented. I mean, it does have that aspect as well. You can use it as such, but if you compare it with a really object-oriented language, like, I don't know, C#, Java, or something, you'll notice that they use classes a lot more, whereas Python is like more on the scripting side of getting things done, and only in more complex projects you will see the classes.
Yeah, because we didn't cover it and I'm seeing it a lot. I'm
Oh,
like,
okay. Yeah. Sure.
yeah,
Sometime we could go over the basics of classes and all that. It can be just a nice way to organize your code basically. When you have to reuse it, it's nicer. Like if I were to do this in a more object-oriented way, the IPs could be loaded into an IP class and all that. In fact, there's like built-in IP class in the Python, like the IPv4 address, I think. Yeah,
I
this one
also
IP.
really want to ask, like, do you think it's gonna make our learning journey easier, knowing
The
OOP?
classes.
Yeah, like
I
it.
think what's important is just like to understand it, but you don't actually have to use it for most tasks because they don't make the tasks easier. It's just for more complex projects. It's a nice way to organize it
Mhm.
and also like to understand what exactly is going on. Like in the example of I don't even know. Like if you were to use this library for the IPv4 addresses, you understand like how you're initializing that class with the address and how the methods inside are organized. Otherwise, it's like even here, if you go inside, the list is also a class in Python. This is the list class in Python. You don't actually have the implementation here, the underlying code. It just gives you like the description for it. But yeah, like at least it gives you a sense of how it works. Like it's also a class, also has like these are like the private methods, the built-in ones, like initializing the list, like how it's initialized.
Mm.
Yeah, so it can be useful for that reason, just for reading mainly, I think.
Yeah,
But
just
yeah,
for being able to read and understand.
yeah, we could cover this. Sure. I'll think about when we should do it.
Because I'm sure as a developer, you need to know that because you're working with a really complex projects. But I don't know, as a DevOps, do we have to know that, or
I
do
think
we
it's
just?
just enough if you like understand the idea. That's the main thing. Like you understand like why it's useful, and when you're using like different modules, in that case, it's really nice that you know that this class was initialized here, and when I'm calling a method of that variable is going to be actually variable the method associated with that object. Yeah, it can be useful for that.
So much for the answer.
Yeah, no worries. Let me know, guys. Any other questions about the project? Nothing? Okay.
No one has any questions? I can. Wait,
Hello.
how are you guys
David.
doing? You know me, I always interrupt you at the very end to make sure people have any, questions or anything.
Yeah, a little
Thank you,
bit
by the
more
way.
interaction.
Yeah, thank you, by the way, for enforcing the Git usage.
Yeah,
Ladies and
we
gentlemen,
have
yeah, we want to make sure that everyone is comfortable
Mhm.
using Git and all that. So going forward, even in the classes, I asked all the instructors to make use of Git more instead of sharing the code in the channels and stuff. Hopefully, they will start using it. But
Yeah, and I
yeah,
also suggest them to put these scripts into one bigger project because otherwise I see how they will feel like, oh, it's useless, to create a repo every single time when I need to work on a small
yes.
task. If you just put it into
Mhm.
this one, for example, you organize it into in a larger one, like DevOps interview tasks, and you keep it all over here. It can be very
Mhm.
useful when you want to view it back.
Yeah, get comfortable, please. It's really important to be able to use this version control system.
Mm.
And I think this is the best time to actually learn this. You
Mhm.
know, resolving merge conflicts and all that stuff. So going forward, Kevin as well and other instructors will be sharing the code through GitHub. So you would have to git clone or git pull or whatever you need to do. If you can't, basically that means you will not be able to get the start their project code or something like that. So we want to make sure that we enforce the Git usage of Git. Does that make sense, guys? Or any objections about that? Or any, what do you guys think? I think that's the only way to learn, because we cover the Git. There might be some people who are coming from, may not be in our batches, but basically we cover Git, I think on the on the third month or something like that. I don't remember. After that, you kind of get, you might forget it along the way. If you're not using it in all other courses, AWS, Terraform, I'm not sure. So that's why we want to make sure that everyone is using, starting from the third month until the end of the bootcamp. Use Git a lot, okay? Even if you are making some notes for your classes or anything, it doesn't matter. Just push, pull, play around with it. It will help you a lot.
Yeah, that's true.
Yeah, and thank you for Kevin. He incorporates the changes that we ask him the very next class. So I really appreciate that. Not all the instructors are the same. I hope they were. So, do you guys have any questions about this question here? I would suggest you to try it on your own, the same solution, then improving this code and removing the parts that may not be needed. So I can give you just one suggestion. Yeah, but Kevin was showing you, so it's easier for you to see. But if you come back, can you come back to code?
Yeah,
Kevin?
sure.
So in this case, in this dotted quad, do we actually need to split this IP address here? Can we just skip that line and read it from the character 3 or something like that? So you can ask
possible.
that kind of questions, and improve upon, and give some other names, meaningful names maybe. So also you can ask a question yourself, like how can I skip the line where it has the same IP address so that I don't do the double, or how can I only print out distinct IP addresses here?
Yeah,
What would you
basically
need to do here?
the idea is to give yourself some tasks.
Yeah.
So you can improve. Yeah.
Also, can you open the logs as well again? The log section. Also, if we had I'm not sure, this is the whole log file, right? Is it?
Yeah, that's it.
Okay.
That's
You
all
can
they
also-
provided.
Okay, you can also ask the questions like, if I were asked, only print the lines that are marked as info or warning or error. You see the middle column here? It says info. Yeah, it could have been error, warning, or something like that, right? So you can just play around with this kind of files. I'm pretty sure there are a lot of log files online as well.
Yeah,
But,
better to use the ones online, because this one is quite messy. So if you guys want to learn, use the log files, I think it's better if you find one online, because this one is just, I added the tab over here and over here just to give an idea of what could be done.
Yeah, we can if we find something, we can share as well. If log file had, let's say, some port number, if I were to ask you, I would like to know which port numbers are being used most, or the requests coming in a lot, something like that. So as you can see, you can come up with a lot of questions just with one log file.
Yeah, even
Does that make sense, guys? Yeah.
You can also ask like how much time passed in between the beginning and the end or something.
Exactly. Or
There's
bring me the log lines between 2 p.m. and 3 p.m.
Yeah.
These are all, a lot of questions just with one log file. You can play around with all of that. And going forwards, I'm assuming we will be doing a lot of those as well. So I think this should be helpful.
Right.
What do you guys think? Any any other ideas, suggestions? No one?
Maybe later. If you guys have any, just let me know also let us know in the Python group.
Yeah, okay, yeah. And also, we still have a lot of time, to be exact, 1 month, I think, right? So I will be covering Kevin March 2nd, I believe. Was it Kevin? March 2nd?
Yeah, right.
Okay. So I will be doing this session on March 2nd.
Hmm. Yeah, that's
Yeah.
true.
I might do something different because you guys are doing with Kevin a lot of, solving questions and lead code and all that stuff. So we'll see. I might have a different content altogether. And also, I would like to comment about the object-oriented programming. Mert asked the question. The problem is, it's when you don't, you need to get much familiar, much comfortable with these type of things, right? Creating function to be able to use the list, sets, and all that stuff, right? Before you switch to object-oriented programming. So that's a problem. Even when you go to computer science degree, we started studying object-oriented programming a year and a half after, I think, or a year after. So in the second grade, that's when you actually start seeing object-oriented programming. For 1 year, we do this type of thing, like functional programming, just solving some questions and stuff like that. Any other questions about that?
Yeah, I remember, Serdar, you explained me multiple times. I'm still asking the same question, but
Yeah.
yeah, I'm just seeing it a lot, and I started thinking like maybe we improved ourselves uh, enough to understand it. Maybe I don't know. I just want to give it a try.
Yeah, we were thinking about too. Maybe we will include it. I'm not sure, but from DevOps perspective, you can ask Ernest as well. I asked them as well. From DevOps perspective, you usually, not usually, 99% or 95% of the time, you usually don't need it, object-oriented programming, because all you do, write some scripts, some short, functions and all that kind of stuff. You can still achieve the same thing with functions and all that. It doesn't mean you have to have that object-oriented programming thing to be able to do something. You
Yeah,
can
that's
still
true.
do it the same way.
I think it's just good. I mean, it could be useful just to be able to read it, to understand the concept, like what is going on. Like the modules use it also. That's why I'm saying, like, if you use the
Yeah.
module, you have to use it like indirectly. That's why I'm saying, like, okay, understandable. If you read the documentation just like this, you won't understand what exactly that is calling the method if it's a class. So for that reason, it can be useful. But I agree that no need to use it actually for scripts in most cases.
That's correct. So once you get more comfortable with all of the stuff, you can still switch your
Yeah, that's
focus to
true, of course.
object-oriented programming.
Mhm.
But I would argue, but I would suggest instead of doing the OOP, if you spend some time on these data structures that we covered, like lists, sets, and all that stuff, I think it will be more useful for you guys. So when should I use lists? When should I use dictionaries or something like that? Maybe their performances and all that stuff. So that might be more useful for you from the DevOps perspective instead of OOP. And we might do something like that on March 2nd. We might dive a little bit deeper. I mean, dive deeper around the topics of these best practices, maybe performance, which one should you use, and all that kind of stuff. I mean, if you're interested. If not, we can still do question solving. Do you guys have any
Interesting.
other questions? Yeah. Also, by the way, here's an idea for our students that probably everyone else is familiar as well. Andrei, Artyom, the students that I know, Mert, Alexei, maybe, I don't know. If you guys remember when you open up your EC2, I think there was some log files. Do you guys remember? I think it was under var log or something like that, which basically logs everything that is happening in your EC2 instance or something.
Mhm.
You can just copy
Yep.
that file and play around with that file as well. I'm pretty sure it has a lot of logs in there. You can come up with a question yourself. How do I retrieve this information from this log file, let's say? Does that make sense?
Thank you.
Yeah, definitely.
Okay. Yeah, that's all I had to say.
Cool.
If you guys have any questions, please. Thank you, Kevin, once again.
It would be an issue with equality because B and B would not be treated equally. So it would still cause issues. Point is that in this case, you have to compare the lowercase or uppercase versions of the elements. In this case, the textbooks. So that's actually the key over here. This is what you have to do. You just have to do like textbooks. You sort it and you enter the key. It's gonna be the reason why I use like string. This is like that's why I said like even if you don't need object-oriented programming you don't need to use it directly, you still will encounter something like this. Like string in this case is like the string class. Whenever you have something like this, you have a string, you have the different methods. It's the methods of the string class. And you can use the upper or lower maybe. And then actually you can just return the textbooks as is. And that's actually the solution. Unless, oops, we don't need to call it actually, sorry. We just need to pass the function itself in this case. So yeah, that's how you can solve this one. That's why it's a bit tricky. It's actually really easy if you know what you have to do, but I understand how this can be tricky. And if you had to do it manually, well, yeah, then you have to manually implement the sorting and even the comparisons. I see how it can be a little tricky, but that's kind of the idea here.
And it still ignores the special characters in the beginning, like in the third variant where there are 2 stars in front of English here.
That's okay. Like it doesn't have to be ignored. The special characters, they will come first. They will be sorted based on the ASCII. So in that case, it's okay. It's only for the letters that we care that they should be treated as such. So yeah, I agree though that it's a bit bizarre to leave it like this. I see how this is a bit dumb to include special characters also. I think because there could be implementations that you're right that doesn't account for these. But yeah, the idea is that only we care about the comparison of the different letters, and they should be compared regardless of whether it's uppercase or lowercase. Yeah. Any questions about this one? Nothing. So here we are actually passing the function. We're not calling it, we're just passing that this function has to be used for comparison. That's the idea. It's like just like when we use the map, you know. When we use the map, we use the same idea. We use the lower function. Like it basically does the same. Like it maps to this string that lower when it does the comparison. So when we have like the map, I'm just gonna pass it as a list, but yeah, when we have the map and we have the subjects, and I hope the order is correct. It might not be. Yep, the other way around. So first we need what we are going to be using for mapping, which is going to be string that lower, and then we're mapping the subjects, and there we go. We have the lowercase subjects. That's what it does internally when it does the comparison. Of course, it's only going to be doing it in a temporary array, maybe something like that. But or only when it's comparing the two words, it's going to first convert them to lowercase internally and compare like that. Yeah, you can also do it with the upper. Just in the right order, of course, it's important. And with the appropriate number of views. Yeah, so that's the idea. It's a bit confusing, right?
So behind the scenes, it just converts everything into lowercase, for example, or uppercase, and then it returns to the initial value, yeah? Sorts it, and then returns to initial.
Yeah, like internally, it so the original ones are left as is, and it's just when it's comparing maybe like two elements, it's gonna go do like, okay, I'm gonna convert this to uppercase and this one the next also, and I'm going to compare them based on that, or maybe it's also creating like a separate array completely, assign some hash value to these different positions and the value. It's like, yeah, the internal implementation. It's an interesting question. I'm not sure. I can just guess, but that makes sense. Point is that it's not going to actually turn it lowercase once it returns the sorted value. Yeah, so I understand. You see, that's the funny thing. Like this one is supposed to be like really, really easy exercise, but the reason why it's rated easy is because once you know it, it's really easy. But if you don't know like what could be done to sort it, it can be very, very difficult. I understand. Like it can be quite tricky to manually sort it using these extra rules. So when you see like easy exercise and you're stuck, just don't feel stupid, because it may as well be the case that it's easy to implement, but not so easy to intuitively realize what we have to do. Okay. I think then that's it for today, but let me know, guys, if there's any questions about this one. Okay, if none, then let's meet you guys next time, and I'll send the homeworks later as always, and don't forget to create a Git repo next time for all this. And also I'm going to share this one. I'm going to share it on Git and send it in the group. All right.
All right. Thank you so much.
Have a nice weekend, guys. See you.
Thank you.